continue with our chemistry chapter. Okay, we will discuss about the hybridization of carbon compounds. Hybridization of carbon compounds. So what do you mean by hybridization? Hybridization means mixing of orbitals. Hybridization means mixing of orbitals. You know, carbon will form bond by sharing of electrons. Okay, it forms a covalent bond. So while the covalent bond is forming, the orbitals in the carbon will mix with the orbitals of the bonded atom. For example, if you take methane, what is the formula for methane? CH4. So carbon, what is the electronic configuration? 1s2, 2s2, 2p2. And hydrogen, what is the electronic configuration? 1s1. So when the carbon and hydrogen are bonding, the carbon's orbitals will mix with the hydrogen's orbital. That mixing of orbitals is called as hybridization. So first we are going to study about sp3 hybridization. sp3 hybridization, it is seen in alkenes. Okay, alkenes means the compounds which are having single bond. So what is this sp3 hybridization? So the electronic configuration of carbon is 1s2, 2s2, 2p2. Okay, so I am going to draw this 1s, I am going to leave. I am going to draw these two orbitals around. So for carbon, first I am going to draw 2s orbital. S orbital, only one box I should draw. Then I am going to draw 2p orbital. P orbital it is having three types: px, py and pz. So how many boxes I should draw for p orbital? 3 boxes: px, py and pz. So 2s2. In 2s orbital there are 2 electrons. So 1, 2. And in 2p orbital there are 2 electrons. Okay, so this is called as the ground state. Okay, so when the bonding is going to occur, what will happen? The carbon will go from ground state to excited state. When the bonding is going to occur, the carbon will go from the ground state to excited state. So this electron which is present in the ground state, it will go to the excited state, higher energy orbital. So in excited state, how you will get this diagram? In the excited state, the diagram will be like this: 1, 2, 3, 4. This electron has come here. Okay, so as you can see, there is only one s orbital, and how many p orbitals are there? 1, 2, 3. So p3. So this hybridization is called as sp3 hybridization. Now if it is methane, this 4 hydrogens, one hydrogen will mix with this orbital, next hydrogen will mix with this orbital, third hydrogen will mix with this orbital, and fourth hydrogen will mix with this orbital. So this hybridization is called as sp3 hybridization. Okay, and the shape of this hybridization is tetrahedral shape. Tetrahedral shape. So I am going to consider an example: methane. Methane, it is CH4. So carbon, I am going to draw like this. So 4 orbitals are there for carbon. I am going to draw the 4 orbitals like this: 1, 2, 3, 4. And these 4 orbitals will be bonding with 4 hydrogen orbitals. 3, 4. Okay, so this will form one single bond, this will form another single bond, this will form another single bond, and this will form another single bond. So if you join them like this, you will get a tetrahedral shape. You will get a tetrahedral shape. So whenever the carbon is having sp3 hybridization, it will have a tetrahedral shape. So this carbon is always surrounded by single bond. So if the carbon is having single bond, then we can say the carbon is having sp3 hybridization. So this carbon is having sp3 hybridization. Now you can see here carbon's orbital and hydrogen's orbital is having head-on overlap. We will call this overlap as head-on overlap. If the bond is formed by the head-on overlap of the orbitals, we will call that bond as the sigma bond. So sigma bond means what? The bond which is formed by head-on overlap of the orbitals. So that bond is called as the sigma bond. So here this is one sigma bond, 2, 3, 4. 4 sigma bonds are present here, and the carbon is sp3 hybridized and the shape is tetrahedral shape. Okay. Now methane, next we will see about ethane. Ethane is CH3 single bond CH3. Okay. So CH3 means one carbon and another carbon. So I told you carbon will have 4 orbitals we have to draw. So 1 orbital, 2 orbital, 3 orbital and 4th orbital. And this carbon also will be having 1 orbital, 2nd orbital, 3rd orbital and 4th orbital, like this. Okay. So H3 means each hydrogen will be forming one bond here, and this carbon also is having H3. Okay, so this is head-on overlap, so this is a sigma bond. So this is also head-on overlap, sigma bond, sigma bond, sigma bond, sigma bond and sigma bond. So this carbon's orbital and this carbon's orbital is also forming a head-on overlap, so it is a sigma bond. And you can see this carbon is surrounded by all single bonds. So single bonds means this carbon is having sp3 hybridization, and this carbon also is surrounded by all single bonds, so it is having sp3 hybridization. And you can see the shape also will be tetrahedral. So if you join this like this, the carbon is getting a tetrahedral shape. And if you join like this, here also the carbon is getting a tetrahedral shape. Okay, so the next one is sp2 hybridization. sp2 hybridization. sp2 hybridization is seen in alkenes. Okay, as you know, the carbon's electronic configuration is 1s2, 2s2, 2p2. So I am going to draw only these two in ground state, 2s, 2p. Okay, so 2s2 and 2p2. So when it is in excited state, what will happen? When it is in excited state, okay, this electron will go to the higher energy orbital. So you will get 2s. So you will be getting like this in excited state. So what is this hybridization? sp2. So this is s, and p2 means only 2p orbital. So only this 3 orbitals will be involved in hybridization. So this is sp2 hybridization, and 1 orbital will not be involved in hybridization. So we will call this as unhybridized orbital. We will call this as unhybridized orbital. Okay, so Now how can we draw this structure? For example, we can take ethene, CH2 double bond CH2. I told you it is seen in alkene. So sp3 means it is tetrahedral shape. sp2 means the shape is trigonal planar. The shape is trigonal planar shape. So ethane means C, C. So carbon we should draw how many orbitals? 4 orbitals. 1, 2, 3, 4. And for this carbon also I am drawing 1, 2, 3, 4. 4 orbitals I am drawing. And H2. H2 means 2 hydrogens I will be drawing. And 2 hydrogens I will be drawing. Okay, so this is an head-on overlap, so this is a sigma bond. This is a head-on overlap, so this is a sigma bond. This is an head-on overlap, so this is a sigma bond. And this is also head-on overlap, this is a sigma bond. So this carbon's orbital and this carbon's orbital is having a head-on overlap, so this is one sigma bond. Now these two are the unhybridized orbitals. So one carbon is having one hybridized orbital, another carbon is having another hybridized orbital. These two carbons will not have head-on overlap like this. They will be attracted laterally. So this overlap is called as lateral overlap. It is called as lateral overlap. If it is a head-on overlap, the bond is called as a sigma bond. If it is a lateral overlap, then the bond is called as the pi bond. So sigma bond, so in the double bond, one bond is the sigma bond, the another bond is the pi bond. Understood? So double bond means one bond is formed by the head-on overlap and another bond is formed by the lateral overlap. The bond which is formed by the head-on overlap is called sigma bond. The bond which is formed by the lateral overlap is called as pi bond. So whenever there is a double bond, that means the carbon will be having sp2 hybridization. Understood? The next one is sp hybridization. sp hybridization. sp hybridization is seen in alkynes. Okay, it's seen in alkynes. So carbon in ground state, how will you be drawing? It is 2s, 2p. So 2s2, 2p, 2. So in excited state, what will happen? This electron will be excited to the higher energy orbital. So you will get 2s. This is 2p. So 1, 2, 3, 4. sp means 1s and 1p alone is involved in hybridization. So these two orbitals alone will be involved in hybridization. So it is sp hybridization. When the hybridization is sp hybridization, the shape is linear shape. Okay, and you have two unhybridized orbitals. Two unhybridized orbitals. Understood? So for example, I can take ethyne, CH triple bond CH. So it is having a triple bond. So carbon, I should draw 4 orbitals for carbon. 1, 2, 3, 4. 4 orbitals for carbon. And another carbon. 1, 2, 3, 4. 4 orbitals. 1 hydrogen. It will form head-on overlap. So head-on overlap is sigma bond. Here also it is sigma bond. Here head-on overlap, so sigma bond, that is the first bond in the triple bond. These two orbitals will form one lateral overlap, so they will form one pi bond, and these two orbitals will form one lateral overlap, it is another pi bond. because there are two unhybridized orbitals. This is unhybridized, this is also unhybridized. Okay, and this carbon also will be having two unhybridized orbitals. So unhybridized orbitals will undergo lateral overlap. So if it is a triple bond, in that one bond is a sigma bond and the remaining two bonds are pi bonds. Okay, and the shape will be linear. So whenever there is a triple bond, the carbon will be having sp hybridization, and you can see the shape is a straight shape, linear shape. Okay, so straight linear means it will be in a straight line. The bonded atoms all will be in the straight line. Okay, practice question, first Roman letter. You must find the hybridization of all the carbons in the following compounds. Okay, so first let us number the carbons 1, 2, 3, 4. So carbon 1, this carbon 1, it is having all single bonds. So if the carbon is having all single bonds, it is sp3 hybridized carbon. And the second carbon, it is also having single bonds. So this is also sp3 hybridized. And third carbon also, it is having only single bonds around it. So it is sp3 hybridized. And fourth carbon also, it is having only single bonds around it. So that is also sp3 hybridized. Okay, and let us do for this one. Now what will be the shape of all these carbons, can you say? So sp3 means it will be tetrahedral shape. Okay, and so let us find the hybridization and shape. So this is also sp3. sp3 means what will be the shape? It will be having tetrahedral shape. So this carbon also will be having tetrahedral shape because it is sp3, and this carbon also will be having tetrahedral shape. Understood? Now coming to this, number the carbons 1, 2 and 3. So carbon 1, it is having one double bond. So double bond means it will be sp2 hybridized, and the shape will be trigonal planar shape. Now carbon 2 is also having a double bond. Double bond is having double bond, and this side it is having single bond. So you should give preference to the double bond. So it is sp2 hybridized. So the shape will be trigonal planar. What about carbon 3? It is having only single bonds. So it is sp3 hybridized, and it is having a tetrahedral shape. Okay. Now here there are two carbons. Carbon 1, it is having only single bonds. So it is sp3, and the shape is tetrahedral. Whereas carbon 2, it is having a triple bond. Triple bond means it is sp hybridized, and the shape is linear. So this fourth and fifth sum will be the homework for you. Okay. So in this you have to find out how many sigma bonds and how many pi bonds are present. Okay. For that we have to draw the structure carefully. So CH2 means I can draw like this. CH2 double bond CH, CH3. Okay. So sigma bond means got head-on overlap, and it will give a single bond. So how many sigma bonds are present between carbon and hydrogen? That you have to find out. How many sigma bonds are found between carbon and carbon? That you have to find out. And total number of sigma bonds you have to find out. And how many pi bonds are found between carbon and carbon? So this carbon and hydrogen, this is the first sigma bond, this is the second sigma bond, this is the third, fourth, fifth, sixth. So there are 6 carbon hydrogen sigma bonds. How many carbon carbon sigma bonds? Here one carbon carbon sigma bond, and in the double bond I told you, in the double bond one bond is sigma bond and another bond is the pi bond. So here another sigma bond. So carbon-carbon sigma bonds are 2. So totally we have 8 sigma bonds. How many pi bonds are there? Only one carbon-carbon pi bond. Okay. Now here CH triple bond CH. So how many carbon hydrogen sigma bonds? Here one carbon hydrogen sigma bond. Here another carbon hydrogen sigma bond. So carbon hydrogen sigma bond is 2. So how many carbon carbon sigma bond? I told you in a triple bond, one bond is sigma bond, the other 2 bonds are pi bonds. So carbon carbon sigma bond is 1. So total number of sigma bonds is 3. So how many pi bonds between carbon and carbon? This is one pi bond, this is another pi bond. So totally 2 pi bonds. So you do for this one you do it as homework.